In this last part of this video, we're still looking at inequalities, but we're going to focus on absolute value. So we've done absolute value equations. And remember, with absolute value equations, we always end up splitting into two different equations to solve. We have a very similar idea here with inequalities, but either we split into two different inequalities or we split into a compound inequality. So you still have two there, but we write it as that kind of sandwich inequality. So let's look at that. Notice in all these cases that your absolute value is isolated first, right? So absolute value is isolated first, just like before. That's really important. And then, of course, C is still a positive number. So you still have that same requirement. Now, if you have a less than symbol, then you're going to split into this form. If you have a greater than symbol, you're actually splitting into this form and you have an or in between. And of course, these still work if you are using less than or equal to, or greater than or equal to. So in this example, notice that the absolute value is already isolated and my 3 is positive, so I can proceed. I have a less than sign, so I'm going to do this. So I'm going to take the inside piece, like it is here. So C is 3 in this case. And I'm going to put the positive 3 on the right and the negative 3 on the left and make a little sandwich like that. And now I'm going to go ahead and solve. So I would add 4 to all 3 sides here. And I have X is less than 7 or 1 is less than X. Now I want to graph this. So I'm going between, let's see, we'll start at 0, 1, 2, 3, 4, 5, 6, 7. And I'm going in between the two values. Now I did have a less than symbol here, so I don't have any brackets. So I'm going to use my parentheses instead. If you want to write it in interval notation, notice that your shading goes from 1 to 7, and they both have parentheses. Okay. Now, our next example is a little bit more challenging. We do have to isolate that absolute value first. So I'm going to subtract the 7 from both sides. And then I'm going to divide by that negative 2. And because you are dividing by a negative, it's still an inequality. You're going to go ahead and flip that inequality sign. So it becomes less than or equal to, and this is positive 10. Now our absolute value is isolated here. Notice that we flip the sign, but also that our right side is now positive. So we're okay to proceed. So we have the absolute value equal or less than or equal to, in this case, a positive number. So our C is equal to 10 here. Now, again, going back to our previous page, think about this. I have a less than symbol. Can you see that? Nope. A less than or equal to symbol. So going into my format, when I have a less than or equal to symbol, I'm using that sandwich format here. So I have that 3x plus 5 comes down. We keep the 10 on the right, and we use the negative 10 on the left and use the same symbol here twice. Okay. Now we're going to keep solving. And again, we're going to work inside to outside here. If it helps to put those lines in just to keep organized, go ahead and do that. So I have 3x is less than or equal to 5 is less than or equal to negative 15. And now I'm dividing everything by 3. So I have x is less than or equal to 5/3. And then on the other side, I have negative 5. Now 5/3 is reduced or simplified, so we can leave that there. And we can also write this in as a graph, excuse me. So I'm going down to negative 5, 4, 3, 2, 1, 0. Now, if you need to, you can always change this over. So 3 goes into 5 one time and 2 left over. So this is the same thing as 1 2/3. That way I just have an idea of where I should be graphing it, right? So it's between 1 and 2. It's not between 5 and 3. So you want to make sure you actually know what that value is. So the value, if you use your calculator, it's 1.666 repeating. So you know how to shade. So I'm shading between that negative 5 and almost 2, but not quite. And I do use brackets because of my equality piece here on both sides. If I want to write this in interval notation, it's -5, comma, +5/3. Again, mirroring that with brackets on both sides. Okay. Now I do apologize. I forgot to write in example 10 here, and I do want to go through this one. I know sometimes I do skip examples, but I do want to go through this example. So let's write it in. Okay, so let me write that example in for you. And it's going to be the same step. We're going to solve and graph, and it is 7 less than the absolute value of 5 minus 2x. So here, my absolute value is already isolated. I'm not going to lie, I don't really like having my absolute value on the right. I kind of like having it on the left better. I find it easier to understand. So if I want to, I can switch this around. I just have to be really careful that I don't change the problem. So notice here that the 7 has a small end and the absolute value has the big end. So if I flip it around, then I can do that, but I just need to make sure I don't change the problem here because I'm not solving, I'm just rewriting it. So I still have the same setup. And now I'm going to notice that I actually have a problem of this style now, right? I have that the absolute value is greater than C. So we're going to set up 2 different inequalities. So our first inequality is the 5x, oops, not 5x, 5 minus 2x is going to be less than -7, or 5 minus 2x is greater than 7. So basically this way just stays, and then I flip it for the other direction there. And now I'm going to go ahead and solve. So on the left, I'm going to subtract 5 from both sides. I'm going to divide by -2. Be careful here. You're dividing by a negative. You're dividing by a negative. So I am going to have to flip that inequality sign. So I have x is greater than 6. And then over here, I'm subtracting 5. -2x is greater than 2. I'm dividing by -2. And again, be careful there. We're going to flip that sign. And I have x is less than -1. Now this is an OR. So an OR is kind of like that idea of union that we saw at the beginning of this section. So we're putting it all together as part of our solution set here. So if you're graphing it, let's see, here's 0, -1, -2, 2, 3, 4, 5, 6. So this one here is going towards the right, right? X is bigger than 6, and I would have a parenthesis. And here, x is smaller than -1. So your answer here is actually in 2 parts. If it's an OR, you keep both parts. You want to put them together. It's a union idea. So if x is greater than 6, or if x is less than -1, that is a solution. So this is what your graph looks like. Now the interval notation is a little bit funky here. You actually write each part separately because you have a space in the middle. So this part here would be -infinity to -1. And then this part would be 6 to infinity. And then what you do is you put that union symbol right in between. So that's how you can write it using interval notation. All right, let's do one last example here. So here we're going to bring in an application. And this is a similar one to the beach example I gave, but we're going to use tolls here instead. So we'll get a little bit more complicated. So you have 2 options for paying the toll so that you can get to the beach. The first option requires purchasing a responder for $20. I'm sorry, this should just be $20. And with the responder, you pay a reduced toll of $3.25 each time you cross the bridge. So I'm just going to make a note here. So if you get the transponder, it's $20 up front plus $3.25 per crossing, right? For each time you cross the bridge. Your second option is toll by plate. And with this option, you pay the full toll of $4.25 and also a $3 administrative fee for each crossing. So if you do not get the transponder, you pay $4.25 per crossing. plus $3 per crossing. So each time you cross the bridge, adding this together, you actually get $7.25 per crossing. Okay. So that $3 administrative fee, I think, is because with pay by, what's it called, toll by plate, they mail you that bill in the mail, so you don't need to have a transponder in your car. And we do this around here as well, but they mail out those bills, so there usually is some sort of administration fee attached to it. Although, so this one's $3, which is pretty pricey, but it's $3 every time you cross that bridge, so it adds up fast. $7.25. Find the number of times you would need to cross a bridge for the transponder option to be the better deal. So if the transponder option is the better deal, that means that it costs less, right? So here our goal is to find the number of times to cross the bridge. So that's going to be our X, is the number of times we cross the bridge. So for our transponder, it's going to be 20 plus 325X, right? Because it's 325 every time we cross the bridge. We're letting X be that number of times. Whereas here, for the, if we don't have a transponder, it's 725, excuse me, X. Because again, we pay that every time we cross the bridge. So we want to know, when is the transponder cost less than, so the better deal, having no transponder. So what we're solving here is 20 plus 325X less than 725X. So now we can go ahead and solve. I'm going to bring this to the other side here. So I have 20 is less than, this becomes just 4X. I'm dividing both sides by 4. And again, it's not negative, so I don't have to flip any signs. And I have 5 is less than X. Now, for me personally, I prefer to read it with my X on the left. So I'm just going to rewrite this. And I'm just going to make sure I don't change the answer, right? So the big side was with the X and the little side was with the 5. So this says X is greater than 5. So that means when you cross the bridge more than 5 times, the transponder, what? The transponder will cost less, right? And is the better deal. So we set up our equation as transponder less than no transponder. And our answer was X is greater than 5. So that means that when X is greater than 5, the cost of the transponder is less than the cost of not having the transponder. So as long as we cross the bridge more than 5 times, then getting the transponder, excuse me, is the better deal. So you can kind of think about this. Typically, if you're going to the beach, if you have to cross the bridge going one way, you probably have to cross it going back again. So, you know, if you go to the beach 3 times, then that's 6 crossings. You're already going to have a better deal with the transponder. So if you think you're going to go to the beach less than that, then maybe you just pay per plate. Maybe if you just go once a summer. But if you think you're going to be going regularly, then the transponder is probably your better option here. So this is just one example. Now this actually works pretty similar to how it does here in Massachusetts. I will note though that if you're using EasyPass, even though you do pay $20 upfront for a transponder, that actually is your money. It gets added onto your EasyPass. So it is an initial upfront fee, but should you choose to not have the EasyPass anymore, as long as you return it, you actually would still be able to use that $20 and get it back by just crossing the bridges and things like that. So it does work slightly different in Massachusetts because, you know, you do have that upfront fee, but that's still your money. It's not that you're paying for the transponder. At least around here, our transponders are currently free, but you just need that initial deposit. And then once you return it, then either you get your money back or you would just, you know, use the money on the transponder until it's empty. But it's just a nice example as well to kind of think about weighing those costs. When does it work to get a membership to something? When is it worth paying that extra money upfront for the discount later on?